Welcome to Unit 2, Day 4, Deductive Reasoning. Deductive reasoning. Deductive reasoning is the process of reasoning logically and drawing a conclusion from given facts and statements. Anytime during the video, you need to push pause so you can write down the notes, or you can hit rewind and replay the notes. You have that option at any time. So, under deductive reasoning, we're going to learn two laws. The first law is called the law of detachment. For the law of detachment, you will be given a conditional statement. Now, if the hypothesis is true, then we definitely can assume that the conclusion is true. Here is the symbolic mapping that we will have to memorize to conclude a statement from facts using the law of detachment. So if we are given an if-then statement, P, arrow, Q, and always remember the arrow in between two letters indicates that the sentence or the statement should have the words if and then. We're going to start off with one conditional statement, and we're going to notice that the second phrase is going to say the exact same thing as the very first hypothesis. Here you see the three dots. The three dots represent therefore. So they are there for a reason. And the conclusion will be Q. The best way to practice is to use some examples and see what we can do. Here is our first example. As always, we want to read the directions very carefully. It says use the law of detachment to give a valid conclusion. If not possible, then write no valid conclusion. Well, one of the first things that we want to do is we want to always label our statements using symbolic notation. If Mark saves $30, so Mark saving $30 is definitely our P. So as you can see, we have a P right here. He can buy a new video game. Right here is our Q. This statement says Mark saves $30, which is the exact same statement as the one above it. So we're going to take a look at our law of detachment. It says if then statement should be first, and we definitely have that. Then the P here should repeat the first P. So what we want to do is take a look and see if that happens. Yes, it does. Therefore, our conclusion is Q. So what should our conclusion look like? There it is. Mark can buy a video game. So that's the law of detachment. Another example. First, what we're going to do, we're going to label all statements using symbolic notation. We see we have an if-then statement, so we definitely have our arrow. When we see if-then, we know it's the arrow with the symbolic notation. And after the word if, or what follows the word if, is our hypothesis, so I'm going to go ahead and give that a P. What follows the word then is our conclusion, so I'm going to give that a Q. If a quadrilateral is a rhombus, then it is a parallelogram. Quadrilateral ABCD is a rhombus. Well, that gets a P because it's saying the same thing as the statement above. Let me check out my law of detachment. Do I have an if-then statement? PQ, yes. Does my P here match the P above? Yes. Therefore, my conclusion is Q. What can we conclude about this statement? That quadrilateral ABCD is a parallelogram. Here, our statements are labeled. It says if you are 18 years old, look at this, then you can register to vote. So our P is that you are 18 years old, and our Q is that you can register to vote. Take a look at this P. This P says Olivia is not 18 years old, so we're going to have to make some adjustments to our letters. We're going to put our negation in front of P because Olivia is not 18 years old. What we want to do is see how this lines up against our law of detachment. So do we have a PQ if-then statement? The answer is yes. Does this second P match up with the first P? Absolutely not, because the second P is negated. So here we have no valid conclusion. We had some students talk about this yesterday, and they said, hey, yes, we can conclude. Yes, we can conclude she can vote. But the statement says if you're 18 years old, you can register to vote. It only tells us that Olivia is not 18. So could Olivia be 2 years old? Absolutely. And if she's 2 years old, can she register to vote? No, she can't. So therefore, folks, this is no valid conclusion. Our next is the law of syllogism. This is the second of our two laws. This one allows you to draw conclusions from two conditional statements, in which the conclusion of the first statement is the hypothesis of the second statement. This is what our symbolic map is going to look like. We're going to go from P to Q, which is the if-then statement, and then we're going to go from Q to R. So what are we looking for here? We're looking for our second Q to match the first Q. And if they do, what we have left is P, which will go to R. So let's get started. Here we have the law of syllogism, and we have the law of mapping, symbolic map here. So the first thing we want to do is we want to label all statements using symbolic notation. So definitely read the directions, use the law of syllogism to give a valid conclusion, and if not possible, just write no conclusion. So here we go. If it is Saturday, I'm going to give that a P. Jake has a baseball tournament. We're going to go ahead and give this a Q. It has an if-then statement, so we definitely have our arrow to represent an if-then statement. Take a look here. It says if Jake has a baseball tournament. Well, we already have a statement talking about Jake having a baseball tournament, so we're going to go ahead and call that Q. The last one says, then he will need to pack his lunch. I don't see anything else that talks about packing lunch, so I'm going to go ahead and give that an R. It is an if-then statement, so I'm going to go ahead and give it an arrow. If I see that my conclusion of one statement is the same as the hypothesis of the other, then I can clearly say if it is Saturday, then Jake will need to pack his lunch. Once you find out that your cues match, you can go ahead and strike them out. Then you will see that your statement, if it is Saturday, then he will need to pack his lunch, will be a valid conclusion. Here's the next one. Take a look at our map, symbolic map, P to Q, Q to R. Want to read the directions? Use the law of syllogism to give a valid conclusion. If not possible, write no conclusion. We always want to start off by labeling all our statements using symbolic notation. Here, if a number is divisible by 12, I'm going to go ahead and give that a P. Then it is divisible by 6, and I'm going to give that a Q. If a number is divisible by 6, oh, that says the same thing as Q. Then it is divisible by 3. I don't see anything else that says that. I definitely have my if-then statements. Do my Q's say the same thing? Yes, they do. So I'm going to go ahead and I'm going to strike out this so that you can clearly see that my valid conclusion is if a number is divisible by 12, then it is divisible by 3. Let's take a look at this one. Use the law of syllogism to give a valid conclusion, and if not possible, then write no valid conclusion. We have our symbolic mapping here until we learn it and memorize it. P to Q, Q to R means P to R. 3 dots mean therefore. We're going to start off by labeling all parts of the statement. If it is sunny this weekend, we're going to give that a P. Then you will go boating. We'll give that a Q. It is sunny this weekend. Oh, wait a minute. Sunny this weekend, sunny this weekend. This is a P. Then you will wear shorts. This is an R. What I notice is that my conclusion of one statement does not match the hypothesis of the other. Therefore, there is no valid conclusion. And what we're really saying is logically, if it is sunny this weekend, is no determination of whether I will wear shorts. There's not a logical sequence that would lead to me wearing shorts. So let's go over what we learned today. Deductive reasoning, the law of detachment, and the law of syllogism. Well, when we talk about deductive reasoning, we have to think about Unit 1, Day 1, or Unit 2, Day 1, when we talked about inductive. So now let's take a minute to talk about inductive versus deductive. With inductive, what do? We look for patterns, and we took what we saw in the patterns and we made a conjecture. So with deductive, we're taking statements and we're logically trying to put them together to come to some type of conclusion. So that was the difference between inductive and deductive. Now we want to refer back to our deductive laws. The first one is the law of detachment, where we notice that we have one conditional statement and one phrase where the P's should match, and therefore our conclusion would be Q. With our law of syllogism, we actually have two conditional statements where the conclusion of one matches the hypothesis of the other, and therefore our conclusion is an if-then statement. So with that in mind, we're going to do some practice out of our yellow booklets, the Unit 2 booklet, and after that we will start the homework.